We're looking at the sky from North Georgia on April 17th around 9 p.m., just a bit after sunset. We're facing east, so the bottom middle of our screen is the eastern horizon, and then curving up the sides of our view is the southern horizon and the northern horizon. And towards the top middle, that's sort of looking straight overhead at the sky. And we see a sky filled with stars. The stars form patterns on the sky that act as landmarks, helping us find constellations. Constellations are areas of the sky with defined borders. Anywhere you point on a map of the United States, you point within the borders of a state. And anywhere we point on the sky, you point within the borders of a constellation. These are the borders of the constellations that are up now. And it's bright patterns of stars that help us find and see those constellations in the sky. The first constellation we'll look for is a famous one you may know of as the Big Dipper. We look for the Big Dipper by looking for 3 stars that form a curved handle and 4 stars that form a cup. It's between north and east, and I'll put up an outline where you can see the cup and the handle, as well as some lines coming off the sort of top and right side that are showing the legs of the bear. This constellation is called Ursa Major. Ursa just means bear, so this is the Big Bear. And the curved handle of the Big Dipper is the bear's strangely long tail. Sometimes here in Georgia, we'll call this the Big Possum. If you follow the curve of the handle, it will arc to a star called Arcturus. That's a little bit further down to the east. Arcturus is a red giant star, and the name Arcturus comes from Greek, meaning roughly guardian of the bear. It's relating to the bear in Ursa Major. Many constellations and star names come from Greek and Roman mythology. But there are other cultures around the world. They had their own constellations, their own names for stars. People that navigated between islands in the Pacific Ocean had very detailed knowledge of stars and used them to navigate across hundreds of miles of open ocean. To sail from Tahiti to Hawaii, it was helpful to know this star, Arcturus. Now, they called it Hokulea, which means star of gladness or happy star. It passes straight overhead if you reach the right latitude on Earth, where you could find the big island of Hawaii. After finding Arcturus, you can continue to follow that curve from the Big Dipper, and we say we spike on to Spica. Spica is a bright star in a constellation called Virgo. I'll put up the outline and picture for Virgo, the maiden. Now, in Roman mythology, Virgo is associated with Ceres, the goddess of agriculture. She's high in the sky through the summer, the growing months. And in Virgo, we find a galaxy called M87. Put up a marker. It's sort of near the head of Virgo. Now, M87 is too dim to see with just your eyes, but if you have a small telescope, you can catch it in the sky. We're going to zoom in on M87, kind of like we're looking at it through a telescope, so we can see it in the planetarium. Now, we do have telescopes at University of North Georgia at our observatory. It is away from city lights off campus, and they are open to the public right now if you make a reservation for a small group. So you can check that out at ung.edu/observatory. But nonetheless, we're going to zoom in on M87 here in the planetarium. So here we see M87. It's an elliptical galaxy. That's a type of galaxy with a smooth, rounded shape. They tend to be older with not very many clouds of gas, not a lot of activity happening. But M87 is unusual because it does have activity. It has a jet of material that shoots from its center. Let's take a look at a photo of that jet taken with the Hubble Space Telescope. This photo is taken in visible light, like we see with our eyes, as well as infrared light. That's a little bit lower energy light than what we see. We see the jet coming out of the center of M87 is glowing blue. It's giving off very high energy light. In fact, it actually gives off X-rays. We're going to take a look at another photo that shows the jet in X-rays. So this photo is showing us X-rays collected by the Chandra X-ray telescope from the jet coming out of M87. We see that it's dotted with knots of gas, and they change shape over time. That's from material in the jet moving out. And in fact, they measured recently the speed of the knots, moving over 6 times the speed of light. Now, in physics, the speed of light is sometimes called the speed limit of the universe. Nothing can actually travel faster than that. The knots only appear to travel faster. It's an illusion that's caused by the material in the jet moving incredibly quickly. It's moving at near the speed of light, which means it's almost keeping up with the very light that comes out towards us to make the photo. So the knots of material that you see in the jet are still moving very fast, about 99% the speed of light. What could launch material so quickly out of this galaxy? A supermassive black hole. The supermassive black hole seen here is at the center of M87. The gas around it is really what we're seeing, gas that's spiraling inwards towards the black hole. It's heating and glowing. This is the closest ever view we've gotten of this material as it's about to fall into a black hole. It's revealing the dark silhouette. M87's supermassive black hole has a name now. It's called Povehi, which is Hawaiian for embellished dark source of unending creation. The word comes from a traditional Hawaiian chant about the creation of the universe. The hole itself is where over 6 billion times the mass of our sun is crushed down into a space that's only as wide as 3 solar systems. This is warping the space around that material, and it's warping it to the breaking point. Not even light can escape if it gets too close, if it falls into the black hole. Now, this photo of Povehi was created by the Event Horizon Telescope collaboration. It was first released in 2019. A team of scientists from around the world collected radio waves with many telescopes and used supercomputers to compile the data into this photo. And it was updated just this year. That's the picture we're seeing here. It's updated to show magnetic field lines that are wrapping around the supermassive black hole. That's the bright streaking that you see. And we're able to measure it by looking at the light that comes to us from this glowing material. Some of the light is what we call polarized. The light waves are lined up to wave in the same direction. And that only happens when there are particles traveling along magnetic field lines to create the polarized light. Or at least that's how it's happening here. And so we can actually map out these magnetic fields around the black hole. Now, we saw those magnetic fields that are likely to be responsible for launching the jet we saw to speeds approaching the speed of light, shooting out material before it reaches the actual black hole. But not all of the material is so lucky. The magnetic fields can actually do the opposite. Instead of shooting material out, they can steal momentum from it and cause it to fall into the black hole. And it's by looking at the maps of these magnetic fields that we can start to understand what's happening to this material as it's falling into this black hole. We can compare our data to models and see that we think the magnetic fields are very strong, and we think that it's modulating the flow of a thin gas as it falls into this supermassive black hole. More study is needed to understand this complex neighborhood around a supermassive black hole. We'll zoom away from M87 and look for another constellation in the sky.